Hi, welcome back everyone. So process-driven losses exist in almost every line, at every factory, for every process manufacturer, things like waste, yield, quality, energy, and throughput. And every manufacturer has an entire operation dedicated to reducing those losses. But why is it sometimes so hard to achieve your KPIs for losses reduction? Liran, we were talking about the super interesting research that Seebo conducted on this question, which came up with some intriguing results. So can you tell us a bit about that?
Yes, thank you, Noah. We've spoke with many of the leading manufacturers around the world. And we were quite curious about their operation and about their challenges and about where they are in the journey of the losses reduction. And we started our research from a very simple, straightforward question. How is your process inefficiencies or losses challenges related to the process of manufacturing looks like? And we've heard almost from everyone something that looks like that. This is time, and this is the level of losses. This is the goal, and this is reality. And then we went straight forward to the next question. That was, why? Why is that looking like that? We got many different answers, but when we compile it to a simple sentence, we got into the manufacturing complexity gap. So this is quite straightforward. The processes are complex. There are many different variables that you can control, and you have many KPIs to optimize. Sometimes they are even coming one on the account of the other. And the processes are complex, but we wanted to drill down even deeper to understand why it's so complex. We continued with the interviews, hundreds of different conversations. We asked many different questions, and we synthesized it to two fascinating parts. The first part is the 10 layers of complexity. When we look on the manufacturing process, there are generally 10 things that make it really complex to understand and analyze. The asset dependency, the multivariable dependency, the batch versus continuous manufacturing. Even in some places, we have batch and continuous manufacturing in the same place. Raw material variability, those are natural products that are not constant. Buffers, nonlinear processes with loops or parallel processes. Inline and offline measurements that should be traced back to the production and back to its own raw material and process parameters. Dynamic cycle times, the takt time, the manufacturing time is not constant. Changeovers, and obviously multi-products. And what makes it even more complex is the data that it produces. So manufacturing data is like no other. It's among the most complex data forms out there because of the challenge, because of the variability. And the manufacturing data produces three challenges. The first challenge is the multi-manufacturing data sources. We have process manufacturing data, raw material data, quality data, and other data sources. There are hundreds or thousands data tags, and they have interdependencies.
Okay, but we're talking about some of the world's leading manufacturers. So they understand their processes better than anyone else. They already have big data analytics tools to handle their root cause analysis. So what's missing?
So in order to perform the analysis well, and in order to provide real value to the manufacturing processes, the manufacturer needs to master two disciplines. One discipline would be the process expertise, which you are right. This is what those manufacturers are mastering. And the other one would be the continuous analysis of multivariable data sources, which some of the manufacturers has experts. But what's most fascinating is that those two disciplines are not merged together. So the challenge is that in many cases, those are different departments, different personnel, and even if you put them in the same room together, it's difficult to embed process expertise into algorithms.
So how can the manufacturers combine these two in concrete terms?
So we were curious about that as well. And we went through an angle and we tried to understand what manufacturers are actually looking for, because the combining of the two disciplines is a mean. And we asked them, okay, guys, what is the thing that you guys are looking for? And we heard that manufacturers are looking for 4 things. The first one is meaningful insights. They wanted the bottom line. Their team doesn't need more work. They need something that tells them where the problem is, and that they will be able to convert it to a meaningful action. The second thing that we've heard is that they need the insights to be continuous. Almost everyone we spoke with told us how complex it is that they need to do an analysis once, and 6 months after, analyze the same production line, even with the same problem. Those manufacturers has from dozens to hundreds to thousands of production lines. Some of them told us they will take them 100 years to cover all the production lines if they would need to do it manually. They wanted continuous insights and scalable insights. And eventually, they wanted something that is designed for the manufacturing teams. Many of them complained about the fact that data science is complex. In the lab, maybe it looks good, but when you hand it to a production team that need to take day-to-day actions, it's not happening well. And you need to take all this complex world and make it accessible to the everyday production team.
So this all sounds great. What's the solution?
So exactly around this challenge, we've built Seebo. We took this gap of the process complexity and the gap of big data analytics and machine learning, artificial intelligence, and process expertise, and we built algorithms that actually understand manufacturing process. We call it process-based artificial intelligence. It starts with a very straightforward look at the manufacturing data. We look on process data, raw material data, quality data, and other data sources, from alternative fuels to weather around the plant. Then, once we have access to the data, we connect it into a one unified multi-source schema. One of the challenges in manufacturing data analysis is the fact that the data is broken into isolated islands. If you want to do deep analysis, you need to collect the data from different places and aggregate it together. For some teams, it takes too long and it's too complex. We built a lot of intellectual property into the pre-processing and data aggregation, especially in manufacturing data. And then we do something that no one else does. We build a digital model of the plant. And using our intellectual property, the tools that we develop, we enrich the algorithm with the manufacturing data. So right now, the algorithm is not looking only at the manufacturing data, but it looks on the data with the context of the process. Then the algorithm can do new calculations that no other algorithm can do. For example, calculate dynamic traceability in the production lines, understand buffers or cycles, and even clean data based on context or differentiation between SKUs. Now, since this world is really complex, we wrap it up with a simple, easy-to-use user interface that is designed for the day-to-day team. And this is how leading manufacturers around the world are reducing their losses today.
Thank you. Thanks, Leon. That sheds a lot of light on the solution and about some of the toughest challenges many manufacturers face. So if you want to see more smart manufacturing content just like this, check out our other videos and subscribe to our channel for updates. See you next time.